What are your thoughts about this session? Well, thank you, Xavier. Thanks for summarizing. Well, I'm not going to summarize the summary. Well, first of all, good evening, ladies and gentlemen. That was a long and packed but exciting day, so I'm going to try and do my best to give you my feeling more than a fully put together summary, and I'll try to be as brief as possible because we've been thinking about all these matters together for quite a long while, and all that can be sometimes a bit complicated. Now, before I talk about our future, the future of aviation, I'll take a couple of minutes to look back over the past. Well, it's not out of sheer nostalgia or out of self-satisfaction, but sometimes thinking about where you're coming from can help shed light on where you are going. So, if you look back to the beginning of the modern era of civil aviation with the first reactor jets in the late 50s, early 60s, fuel burns, and still talking about fossil fuels, per seat and per kilometer were divided by a factor of over 4. I'm not sure that at the time of the pioneers in the 50s or 60s, telling them that we would only burn a quarter of the fuel, they would have believed it. And yet we did it. And so we can already be reassured about the ability that this industry has and its environment has to take up the new challenge before us, which may be an even bigger order of magnitude. And since we've made quite a bit of progress, and so efficiency, it can only be a 1, and trees cannot grow as tall as the sky, well, it's a huge challenge. Yet, looking at the past of global aviation, I'm confident about our innovative capacity to find the solutions that we need. Another thing that happened over the last 50 or 60 years is that, on average, but very, very steadily, air traffic has grown twice as fast as global wealth production, i.e. global GDP. So there's one consequence now. Well, I mean, last year, nearly 5 billion people were transported, and based on this success, it's become maybe not the biggest contributor, but a non-negligible contributor to global warming. And so the challenge we mentioned can be taken up, but there's no two ways about it. We can't go on that way. However, the fact that for 50 or 60 years, it's been like a Newtonian law of attraction, the desire to travel, it's a number of inhabitants in the region multiplied by the number of inhabitants in the other region divided by by distance and cost squared. And so we've made great progress. It's because of how cheap costs are for a fuel that we were able to make that a very attractive mode of transport. The average American flies twice a year. Some may say that it's a lot. All right. But the average Chinese person 20 years ago flew once every 100 years, and now it's once every 5 years, and they still want more. Chinese civil aviation traffic has been booming, and it's now come back to pre-crisis levels. And not even mentioning emerging countries that are not yet at once every 5 years. And who would we be to deprive them of that ability? We've moved from caves to villages to towns and countries, and now our planet is our global village, and this desire to travel is a strong expectation. It's maybe not an existential need, but maybe. And I'm convinced that our community will be able to take the gauntlets, and so it would be a shame if we didn't try. And so imagining a rationing or coming back to limited traveling abilities, that's difficult for me. So, okay, we are hopeful we'll make it, but how? That's where it gets a bit more complicated. And I would say that was sort of my feeling at the beginning, and it's now even more at the end of this day. Answering your question about what's going to win in the end, is it non-fossil hydrocarbons, synthetic, made from biomass or captured CO2, or is it hydrogen? I don't know. I think that honestly nobody knows, and it's not really a matter of knowing what planes are going to look like in 2050. The matter is to make it happen. So I'll share my personal opinion. It is what it is. It's not based on any scientific studies or full-fledged studies. It's just common sense. Electric, that would be great. Yet electricity storage, batteries, accumulators that could achieve energy density levels that are compatible with the flight equation of a commercial airliner. I can't see that happen, even at the lab stage or even at levels, TRL levels 1 and 2. I don't know, maybe that will happen, but it's not yet mature enough, to say the least, for us to be able to bet on such a formula. It's, well, we could try our luck with air taxis with very limited flight capabilities, but betting heavily on electric for civil air transport, personally, I think that that may happen one day, but it's too early. But a good dose of hybridization is something that I strongly believe in. Personally, it's not going to be plug-in, but it doesn't matter. For instance, you could reduce, to answer your question, Xavier, about whether we'll still have the 10 to the -9, it's vital. Otherwise, there is going to be no aviation. However, no, I used to work for an aircraft engine manufacturer. Sometimes they break down. It's not 10 to the -9, but 10 to the -6. And so aircraft are made with engines that are comfortable so that they can be sure in every flight phases, including at takeoff, with engines that break down. So if you have some hybridization, at first you could have rotary wing aircraft like helicopters, so you could have less conventional power reserves that won't be huge, but I mean small streams make big rivers, so partial hybridization, why not? So I think that electric is not going to be a major priority. So physical research, fundamental lab research, okay, why not? Hydrogen is fascinating. We would all wish for hydrogen-powered planes. Because if the hydrogen is produced cleanly, that solves the matter of CO2. And then energy density per mass is attractive. It's 3 times better than kerosene. So, of course, you've got to take a look at this and even do a bit more than this. However, It's a great challenge, but a challenge nonetheless, and I hope that it will be able to motivate the best talents. For engines, it's not that simple. There's a bit of work. I can't see any showstoppers, no impossibilities. But there's quite a bit of work to do. On the system side, there's even more work, as was discussed in passing in very precise terms. So systems encompass onboard systems, but also everything that's upstream. So we're talking about a new world, at least new airports. And there is one thing that I'm concerned about with hydrogen is the volume density. So all other things being equal, they are not going to be equal, but all other things being equal, you need a tank that's 4 times as large, and it needs to be insulated correctly. So I can't imagine what planes would look like with that. It would be possible, and as was mentioned, it would be more possible for short to mid-haul flights rather than long-haul flights. And so why not start with what is the most accessible, keeping in mind that the main challenge is rather the contribution of long-range flights rather than short-haul flights. So that would still be some that is quite difficult to integrate into the current system. So that would be a real breakthrough. I'll take an image. I like to talk in images. We saw a parallel, which is only that, a parallel with space. We can all picture what Ariane 5 looks like with its big central body. What's the central body? It's mostly a hydrogen tank and an oxygen tank. Oxygen is denser, but 3/4 of it is hydrogen. Okay, so it propels. That's the propellant of the main stage. In fact, that's the second stage engine, but it's ignited on the floor, on the ground. It's the Vulcan engine. It has 130 tons in thrust, so it's similar to the biggest. It's a bit more than the biggest engine on the A350. And just look at the sheer size of the tank. And so real engineers are going to scream, and so it's about the same thrust as the engines on a very long range, but the engine only runs for 10 minutes. Of course, the efficiency is not the same, and so on and so forth, but that really gives you an order of magnitude of the challenge. I'm not saying that it can't be addressed, but the cost of the volume density and volume energy density of hydrogen, that's about physics. That's the law of physics. You can invest however much money you want. You can't change the laws of physics. So hydrogen, yes, it's a great project. Yes, that can mobilize and drive a lot of technological development, so on and so forth. But personally, I think that at the same time, and with a more short-term view, I would invest a lot, on the one hand, on, I don't know how to call them, SAFs. Well, because that way that obfuscates things a bit. I don't know what dose of biomass versus captured CO2 combined with hydrogen I would be unable to say, but I really, really look forward to that happening, because that could happen if we want it. That could happen relatively quickly, and I think that A, it's important for the planet not to waste any time, and B, it's even important at an almost moral level for the nation, if you get my drift. As soon as you can demonstrate that it won't be in 2050, but in the next few years that will start to reverse the trend, well, I think that altogether we can be more confident about the end goal.
All right, and to wind up, I said I would be brief, and I wasn't brief, but sometimes you get carried away by your passion. Anyway, it may be hydrogen or SAF as a step on the way, or some sort of combination. One thing is incontrovertible: we have to continue making progress on the mass, the aerodynamics of the cell, on the performance of the of ATM, of the air traffic management system, and of course the efficiency of the engine, the yield, the efficiencies of existing IC engines. Well, it's not the same as a piston engine. A piston engine is below 50%. We are just below 100%. I mean, way beyond 50%. There's some headway, but not as much as all that. But the propulsion efficiency, because this is on air, not on tracks, on the road, there is some ways to go, and that's difficult because you have to, I mean, theoretically take on an infinite amount of air and accelerate it down to nothing. I mean, taking in on all the outside air is, I mean, obviously a complicated thing. But hydrogen or SAF, which probably will be more expensive, but reducing by 35 or 40% the consumption of the propulsion system is our priority, and we waste no time or money by doing just that. So, but it means it's a convergence. It's concurrent technologies that will lead to the desired outcome. But finally, as SAFs or new non-fossil-based fuels, these well, the advent will not be determined by market forces alone. In fact, what you do need to make this happen is a form of political leadership, and it would be desirable for such an impulse to be well thought out. And I mean, it's all easy to slap taxes on systems and throw money at others. But if you give me, say, 30 seconds of my time, electric cars, electric vehicles are great, if only to improve the air quality in cities. Regarding CO2 emissions, in those countries where electricity still is high carbon. By the way, this is not the case in France, because in France, thanks to nuclear energy, we do have a low carbon power generation. But in those countries where there is still a high carbon power generation, you need 100,000 kilometers for the electric cars to have a better carbon footprint than the ICE engine. Maybe we put the cart before the horse then, but nonetheless, it goes to show that before you decide to tax certain types of engines and subsidize others, you have to take stock of the full situation. Aviation is a global industry. It complicates matters in terms of governance, but you should remember this was done before. This has been done before. If there is international air transport at all, it is because a large number of countries got together back in 1944, even before the end of World War II, even before the UN was set up. The Chicago Convention that founded ICAO happened before the end of the world, and without that, there would be no international aviation today. Now, it's beyond my reach, but I believe that the climate challenge, which should and can be addressed, can be met technologically. This requires a sort of it does require a sort of international consultation that would be sort of a round two of the Chicago Convention, very much like the founding of ICAO itself. Well, it's true that in the Chicago Convention dated back to 1944, and one of its purposes was to bring about peace in the world, and we can certainly hope that there will be just that for future generations. Well, in any case, many thanks for your conclusions and recommendations. And coming from a wise man, a great engineer, a man with remarkable experience, I certainly hope that all our listeners, especially the younger generation, the students and others who listened in, I hope you were able to, and you enjoyed these discussions and exchanges, 8 hours long. Many thanks for your attendance. Many thanks for your questions and comments. We'll meet again tomorrow at 9 a.m. Good night, and thank you, Jean-Paul. Thank you, Xavier. Goodbye, everyone.